Gay-Lussac's law. Gay-Lussac's law, or what we call a pressure law. The pressure law or Gay-Lussac's law is we have the fixed mass. The pressure law or Gay-Lussac's law says that the fixed mass of a gas, that's the fixed pressure of a gas. The fixed pressure of a gas is directly proportional to its absolute. The fixed mass of a gas is directly proportional to the absolute temperature, provided the volume remains constant. Where we have the P is proportional to T, we call it equation 1. Where we have the proportionality is equals to K, we call it equation 2. We substitute 2 in 1, we have what? P is equals to KT, equation 3. Then you make K subject of formula, divide both sides by what? T, divided by what? T. T cancel T. We have K is equals to P over T. We call it equation 4. Therefore, this is the formulas, or this is the formulas of the Gay-Lussac's law or pressure law, where we have the P1, T1 is equals to P2, T2 respectively, as the case may be. And this is the formula you're going to adapt to solve equation of the Gay-Lussac's law. And to do that, we are plotting the P against what? V, where we have the calibration of like this. We now proceed into the general gas law. The general gas law is the general gas law. The general gas law can be obtained from the Boyle's law, can be obtained from the Charles law, and also what? The pressure law, respectively. And based on this, we have the Boyle's law. The formula for Boyle's law is equals to the PV, and the formula for Charles law is equals to P over T. Yes, oh sorry, V over T. While the general formula of the pressure law is P against a T. If you observe from the mathematical expression, we have PV, which is equals to V over T, which is equals to T over T. Automatically, this T, if you find the LCM, you have T. Right? So we have the P is also here. The P is here, we can have what? PV. So the general formula of the general gas law is PV divided by T, meaning we have the P1 V1 over what? T1 is equals to P2 V2 over T2, as the case may be. And this is the general formula of general gas law, respectively. And that leads us to the ideal gas equation. Ideal gas equation. When we say ideal gas equation, what is ideal gas? Ideal gas is a gas that specifically obeys general gas law. And what is the general gas law? The general gas law is the Boyle's law, Charles law, and the pressure law. So thereby, any gas that obeys the Boyle's law, Charles law, and the pressure law is referred as what? Ideal gas equation, and it's different from the real gas equation, because the real gas equation is the types of gas that does not obey general gas law, as the case may be. And what is this formula for ideal gas equation? The formula for ideal gas equation is equals to P. The general formula for ideal gas equals to PV is equals to nRT. I'll repeat again. We have what? PV is equals to nRT. What is P? The P is pressure in millimeter mercury or in atmosphere. The V is volume. The N is number of moles, and R is the R gas constants, and the T is the temperature, as the case may be. And that leads us to the kinetic or molecular theory of gas. The kinetic or molecular theory of gas is a theory of gas that explains the behaviors and the fundamental phenomena of the reactions of the gas molecule, respectively. And when we talk about gas molecule, the gas molecules are just molecules that have a higher kinetic energy. They have higher kinetic energy because they have the power to move and collide with one another with the wall of the container. 2. The gas molecules also are molecules that specifically are random constantly in random motion and move with the opposite manner and collide with wall another and also with the wall of container. And also we have the molecules of a gas, respectively. The volume occupied by the molecules of a gas is negligible compared to the volume occupied by the gas. The duration of a gas, the rate at which gas molecules collide, is negligible compared to the time of the collision, as the case may be. And gas are constantly in perfect inelastic manner, meaning they move and bombard each other irrespective of the position, respectively. And this is where I will stop from the general gas law. Thank you so much for listening. My name is Muhammad Nasser Abdul Rauf.